You know that feeling, right? Staring at a spreadsheet so full of numbers your eyes just glaze over. Well, that mountain of data is actually holding a story. But to find it, you need the right tools. Today, we're going to learn how to turn those raw numbers into a clear, compelling visual story.
And it's so true. Raw data is just noise. The patterns, the trends, the actual story you're looking for is buried in there somewhere. Our whole goal today is to find the key to unlock it.
And yeah, this is what that noise looks like. Just a wall of numbers, categories, observations. I mean, it's all technically precise, but it's not insightful. Without context, it's just static on a screen. But then you do this. With the right visual, all that noise suddenly resolves into a crystal clear picture. Instantly, we can see relationships and get the core message. That is the power we are talking about. So let's really dig into this. Why is a spreadsheet so terrible at telling a story? And why is a good chart so much more than just a pretty picture? Why is it an absolute scientific necessity? Well, it really comes down to a few key things. First, a good visual brings clarity to something that's super complex. It helps our brains do what they do best, recognize patterns, like a worrying trend in coral reefs. It makes comparisons totally effortless. And this is a big one. It's all about communication and integrity. A clear graph can actually drive policy decisions, but only if it presents the data honestly. Okay, so where do we even begin? Well, it starts by shifting your mindset a little bit. You're not just making a chart. You're actively deciding which story the data needs to tell.
And here is probably the single most important rule of the day. Let the data guide you. You don't pick a chart because it looks cool. You pick the chart that perfectly matches the story your data is trying to tell. It really is the most fundamental decision you'll make. All right, enough theory. Let's put this into practice. We're going to start with one of the most common data stories out there, making comparisons between different groups.
So let's imagine for a second you're a marine biologist. You've been out counting fish at 2 different reef sites. The question is simple. Which site has more fish and what kind? So here's the raw data. The information is all there, sure. But if you try to quickly compare the species, it takes real mental effort, doesn't it? Our brains just aren't built for this kind of thing. But now, look at this. With a simple bar chart, the comparison is instant. There's zero mental work required. The story just pops right out. Site A is dominated by one species, while the others are much more balanced over at Site B. See? Story. Okay, let's switch gears. What if we're not comparing separate groups, but instead we're trying to understand the makeup of one single thing? For example, what percentage of this reef is living coral versus, say, algae or sand? For that kind of parts of a whole story, a donut chart is perfect. It gives you this immediate, intuitive feel for the proportions. You can see at a glance that coral is the big winner here. So here's the key takeaway. Bar charts, they're your go-to for comparing separate, distinct things. Donut charts, they're for showing how a single thing breaks down into its parts. Each one has a very specific job, and if you use the wrong one, you end up telling the wrong story. But what if your story isn't about comparing categories? What if it's about seeing the shape of your data? How it's all spread out. Well, for that, we're going to need a different tool altogether. Meet the histogram. Now, it might look like a bar chart, but trust me, there's a huge difference. Instead of comparing separate categories, a histogram shows us the frequency of a continuous measurement, like fish length, by grouping it into these little bins. So, let's go back to our fish. Imagine we've measured, say, 150 of them. The question now is all about their size. Are they mostly small, mostly large, or is there a pretty even spread across the board? And the histogram gives us the answer. We can see a really clear peak. The vast majority of fish are falling into that 10 to 14 centimeter size class. This isn't just a random spread, it's a real pattern. For a biologist, this could mean a successful recruitment event, a healthy new generation of fish. Okay, for our final data story, we're going hunting for hidden relationships. This is what you do when you want to see if 2 completely different measurements are secretly connected to each other. Now, to do this, you need what's called bivariate data. Sounds fancy, but it just means you take 2 different measurements from the same thing. So, for every single animal, you measure both its length and its mass. The question we want to answer is pretty simple. As an animal gets longer, does it also tend to get heavier? Is there some kind of predictable connection between these 2 variables? The tool for this job is a scattergram. Think of it like this. Along the bottom, you plot what you think is the cause, in this case, length. Then, up the side, you plot the effect, the mass. Each tiny dot on that chart is a single animal, showing both its length and its mass at the same time. When you plot all the dots, the pattern that emerges can reveal a really powerful relationship. So we've seen the power of choosing the right chart. But that choice, well, it's only half the battle. Because even with the perfect chart, it's actually pretty easy to mislead people. So the final and most crucial step is presenting your data with integrity. This all comes down to one word: trust. A chart without labeled axes is basically meaningless. A chart with a weird, distorted scale is, frankly, a lie. The goal is always clarity, using things like legends and colors to help people understand, not to confuse them. And it all circles right back to our central theme. Choose the right graph and then present it honestly to tell the true story of your data. And we're going to leave you with this thought. A visualization is never neutral. It doesn't just display facts, it frames them. It actively makes an argument. So the next time you build a chart, just ask yourself, what argument am I making? And am I making it clearly and honestly?